In order to understand the unit circle, we first need to talk about the benefits of a right triangle with a hypotenuse of 1. Here I took a right triangle. I made its hypotenuse 1. I called the two perpendicular sides A and B. I also called the angle that the hypotenuse makes with the horizontal x. Now let's see what will happen in this triangle. In this triangle, when I want to write sine x, that is opposite over hypotenuse, it will be b over 1. When I want to write cosine x, from adjacent over hypotenuse, it will be a over 1. Now b over 1 equals b and a over 1 equals a. So sin x equals b and cos x equals a. This means the following. Here, wherever I see b, I can write sin x. Wherever I see a, I can write cos x. Let's do this. So it's becoming a bit clearer why I chose the hypotenuse as 1. Because if I choose this as 1, the side opposite this angle becomes sin x, and the side adjacent to it becomes cos x. You might ask, what good is this? It has many benefits. For example, if you first apply the Pythagorean theorem, that is, the sum of the squares of the two sides that meet at a right angle equals the square of the hypotenuse, you actually derive one of the most fundamental identities in trigonometry. Or let's say we want to write tan x. I can also easily show that, for example, when you say opposite over adjacent, that's sin x over cos x. Or when finding cotangent x, which is adjacent over opposite, that's cos x over sin x. That's not all. Let's say, since this angle here is x, I took this one as 90 minus x. Now let's write the trigonometric ratios for this angle here. This time the side opposite this angle will be sine a. Sine of 90 minus x. Its adjacent side will be cosine of 90 minus x. In this way, we can easily see the identities related to 90 degrees thanks to the right triangle. The real benefit of a triangle with a hypotenuse of 1 is seen in the unit circle. I had artificial intelligence draw a unit circle. Here's its feature. Now, since this is 1 unit, we know that the side opposite this angle is sine x, and the adjacent side is cosine x. This part shows me sin x, and this part shows me cosine x. Now let's play around with the angle a little. For example, let's give it a small angle first. For instance, when I set the angle here, the opposite side forms a segment like this. Let's look at the sine value. 0.559. When I move the angle over here, say to 80 degrees, what do I expect to happen? I expect the value there to increase. Look, I set it to 67. Now there's a larger value here. Why? Because this side got longer. But at the same time, the horizontal side got shorter. That's why the cosine decreased. If I move this a bit further, you'll see again that the opposite side shows sine x and the adjacent side shows cosine x. And this will give me a huge advantage, but that's for another video.